I'd like to welcome you all at Delody for the Geek to Geek event. So I'm Thomas. I'm CTO of Delody. The other Thomas is there. He is the so-called CEO, but we don't care much for that. I'm very glad that you're here today, that you come from the cold into that cozy place, and at least when there are so many people, it's pretty cozy. Our topic today is JavaScript everywhere, and I don't know how much people of you started writing JavaScript for Netscape 3 or so. There's so much young people here. There are not so many of it. The development of JavaScript in the last 20 years, let's say 20 years, it's pretty amazing today. I think it's one of the most used. Stop this. JavaScript is one of the most used languages, and I bet it's a pretty big share on GitHub. There are so many projects, so it's pretty impossible to have an overview of all projects that are running there, all libraries, all the things that you can do. You can write native applications for mobiles. You can write native applications for desktop. You can write server applications. Of course, still the browser part, and it's such a wide bandwidth that JavaScript is serving today, though that's a pretty good topic to reinvent, or not reinvent, or to wake up Geek to Geek, which is the first one, I think, since 1.5 years or so. And for this reason, I'm I'm even more glad that you are here and that so many of you are here. Is there anyone that joined the old Geek to Geeks? No, all new people. So at least nobody wants to say that he's here. Okay, just to hand over to Jonathan. This event is sponsored by talent.io and Delody. We have managed to, talent.io have managed to get some great speakers here. We have managed to have a nice room and have some beer and drinks and so, and we organized it, and yeah. So let me pass the mic to Jonathan, who wants to introduce the speakers a bit and wants to tell a bit about what is talent.io, because talent.io is not just a recruiting company.
Good evening. Oh, hi. Good evening, everybody. I'd like to extend my warm welcome to. I'm Matthew from talent.io, but Jonathan is also the first speaker, so that's all good. Firstly, yeah, this is the first event that we've run together as talent.io, Delody, and Geek to Geek, and I would like to thank Geek to Geek for welcoming us with such open arms to their community. So it's lovely to be a part of it. From our side, as talent.io, it was all about trying to make sure that we are adding as much value as we can to the Berlin tech community. And by bringing so many people together tonight, I think that's the first step in that direction. So that's really nice to see so many faces. The first thing that I would like to do is maybe just tell you a little bit about who we are, so you know that up front. And you're going to see probably quite a lot of really high-tech and state-of-the-art presentations tonight. So I thought I should probably follow suit, and I've come up with this picture to describe what a selective recruitment platform like talent.io does. So it's pretty clear if you can see. But we are the bridge that connects awesome companies that are based in Berlin to awesome candidates that are also based in Berlin. So that's why we try and push this whole premium aspect. So we only work with the best companies, you guys, and obviously also the best candidates, you guys as well. So that's what you're getting on our platform. It's a very direct relationship that you have, again, as you can see in the picture. So candidates, engineers, you will talk directly to companies and awesome companies. And clients, we have a couple of them here tonight. Give us a wave. Yeah, Julian, cheers. You talk directly to awesome candidates. And yeah, these bad companies and these bad coders, they They don't join. Okay. If you have any questions, I can draw you the picture again later. It's pretty easy. So moving on to maybe who our target demographic would be. Clients, if you're based in Berlin and you have an awesome product and you need more awesome people in your team, you should probably come to us. Why? Because you only pay if you make a hire. It's a direct, transparent dialogue that you have. And in comparison to a lot of other social media channels, you will get a 100% response rate on any messages that you send over our platform. You can browse at your convenience, and I think that's quite cool for a potential customer in Berlin. Because often, if you're working with a recruitment agency or something, you'll maybe get called up, hounded, harassed. Whereas with our platform, you can simply log on and peruse at your leisure. And then our candidates are all pretty proactive as well. They've signed up to the platform and want to talk to you. A candidate, again, you're in Berlin or you want to move to Berlin. You're looking for a new job and you're really good at coding. And yeah, why should you join up to talent.io? It's because companies, awesome ones, will apply to you. There's no middle person involved. You get to decide who you talk to. If a client that you're not particularly interested in reaches out to you, you can just swipe left. You can't actually swipe, but you can send an email, which is also cool. And it's free, so why not, right? That's as good a reason as any. So what do I want you to do after this presentation? Well, firstly, enjoy the presentation. We've got some really great speakers tonight. And I'd also like to extend my thanks to the speakers at this point. We have Lian, who has come all the way from Hamburg to be here tonight. So a round of applause, I think, is in order for that already. We have my compatriot from England, Jonathan, somewhere. There he is. So, welcome. Pretend you did, it'll be fine. He came all the way from England tonight, so it's huge. And from France, yep, there we go, international tonight. Okay, we've got Frédéric, who's from Campanda, who will be giving us a talk. So thank you also for giving up your time and your evening to talk to us all tonight. That's really cool. So Frédéric. Okay. We've also got some awesome free food at the back there. It's in some cartons and some wraps. That's courtesy of Green Gurus. Very healthy. If there's some left at the end, take it for your friends, take it for your flatmates, take it for your lunch tomorrow, do whatever you want, really. Make sure you get home safe tonight because it's cold, icy, you don't know what could happen. And then obviously sign up to talent.io and feel great about life afterwards. That's pretty much all I wanted to say tonight. So without further ado, I will hand over to our first speaker, Jonathan, and I'll give you the floor.
So, firstly, anyone there not know about ReactJS? A couple, okay. But you're all JavaScript programmers, right? Oh, rather. Hands up if you're not a JavaScript programmer. You know, no, okay. So there's a few. So some of it might need a little explanation. Feel free to shout out. So I'm from a company called Nextcoder. We have these lofty ideas of helping the world through code. That's our sort of mission statement. Meaningful digital products in new ways. Nextcoder sets out to focus on how breakthrough technologies can tackle exceptionally fast-growing social problems. Basically, we build stuff for social projects and try to develop the best using the newest technology. This is a case study, the presentation. We're a charitable foundation who provide counselling to people who've suffered. Usually this is refugees in war-torn regions or people escaping from war-torn regions, and they have a lot of problems. And they need this counselling in their own language and culture. So a massive number of these are displaced. You can't do it in the place they're in. So what they wanted was a video counselling platform with a localized booking system. So Well, I'll just show you what it is first so we can talk about it. So you have a... This is not England. No, this is Berlin. Oh, sorry, yes. Oops. Giving the game away. Actually, I don't know how to put this one on that screen. This should be up. Ah, here we go. So this is the platform we built so far. So it's a React platform with Redux and a Node backend. And the clients can come in, they can register or log in, and then they can schedule an appointment. They can see the availability of their counselor, book the appointment, view my appointments, and then this bit's funny, they can go to the appointment here, they connect to a video, have a chat, that kind of stuff. Give feedback at the end. And they can do some other sort of counselor-related things, like add a self-assessment that talks about their problem, and so on. So they needed to build that. Back to the presentation, if it can be found. Yeah. So we dug into this, and we had a great time with React. Everything was nice. Redux, everything nice. But we found a few things out as we did it that I'd like to share with you. And these are sort of like tips and tricks. And even if you're not doing React, some of these might apply to problems in other frameworks like Angular or Ember. But I'll just run through very quickly. I know one of my co-speakers is going to talk more about testing later, so I hope I don't do... It's only a very brief bit on that. But I'll run through the idea quickly. Let's see. So firstly, there were some constraints. We had to use a provider for the WebRTC as a partner. This may change in the future, but we had to go with cost-effective and had a JS library API. MySQL. React, because it's fast and cool. We like the functions as components, and it's quite easy to get up and running, actually. Redux a bit more complicated, but we like the functional approach, mutating state. And then we did Node so that we didn't have to think about another language while we were developing, and also kind of like Express. And it had the ability to deal with MySQL, so enough stuff. So the first thing that we had to deal with was this third-party API from TalkBox. These provide the video WebRTC. So normally you get a lot of these around where there's some API with a global namespace. You're told to use script tags to get a script in, and then you pasted some JavaScript, and it looks something like this. So this is their Hello World example. Now this is nice enough when you don't know when you're not doing anything complicated, where you just want to have a web page where you can integrate something from a third party. But for our purposes, it was a little bit awkward. Firstly, it does some magical DOM appending. So it will connect you, start a call, but it will magically write some video element into the DOM. And obviously with React, I don't know if you know this, but it has the virtual DOM. And if you do your own mutation on the DOM, it'll just get re-rendered out of the DOM the next time React operates. So we were a bit stuck with that. And then the OT global was not importable. You couldn't require it or use it as a library or anything like that. There was no way, which made it slightly awkward for things, especially testing. So we did a couple of things to get around this. So, and these may apply to general cases where you have these kind of APIs. Firstly, the DOM manipulation. So with React particularly, to get around that, we disabled the API actually inserting the DOM. And it's still, we wanted really to get at the video stream, but this was a little bit kind of difficult to do. And they didn't have the video stream attached to the video element or anything like that. And it was sort of undocumented. So in the end, the way we did it was the refs and append child, which I think is the only way in React to to handle that kind of gracefully. You have to be a little bit careful about when you do it in the life cycle. Yeah, so that was the first trick, dealing with DOM elements in React. The second thing was how to deal with this global. First thing, this might apply again to any other testing you're doing. We wrapped it in a small wrapper function that just only gets loaded in the browser. So window.ot, the global, gets exported. And then when you use that, you just get the global there with import. And now when you actually want to use something like Jest, we wanted to use Jest for testing, we could use the mocks. And we could actually create a mock. And then we could, when we imported it, we could actually mock that OT wrapper. And when we imported the OT, the code that uses OT, now we're using our mocked OT. So the general principles here we learned was deal with the DOM elements with refs, and using globals, you can use a wrapper and mock. Everyone roughly following this so far? Might get a bit... hands up if you don't understand anything at all about it. So we're good, okay, good. Hands up if it's too easy. Okay, all right, we're all right. We're on the right page then. Then we had this problem with testing, and the thing was, we know we need testing. I mean, it's quite a complicated app with lots of stuff the user can do, lots of state changes, especially if you think about the video. You can be attached, you can be disconnected, you can have a bad quality signal that gets degraded. There's interruption from one end or the other end, and then there's also the chat. So there's a lot of state operations we're doing, a lot of logic in there. Yeah, the problem in general, testing front ends is hard and slow. This is basically, we tried things like Nightworks. I mean, from the Ruby world, I know Capybara and things like this with lots of Selenium-based browser testing, which is quite good, but it's very hard to run it every time as a developer. And you often get things that fail in some cases and then pass the next time. They're sort of unpredictable, non-deterministic sometimes. And that's tricky when you want a very quick development workflow. Test code, test code. So we went for the unit-based testing. We decided that the structure of state, so in a React app with Redux, there's a sort of contract which is the structure of the state. So testing the reducers is probably one of the best places to do things. You're actually testing what happens when you apply an action in the reducer. So you can see here there's a subtle bug, for example. Anyone know why the second one wouldn't work? Of these two. It's a good idea, but not quite. Well, maybe I'm wrong. Maybe the binding of this would break it too, but I think it's actually because it doesn't return anything. So there's stuff like that where you can just type, you could think you got it right, and these kind of tests would really capture those. So when you're doing lots of development very fast, it's handy to have them. Yeah, and that's basically where our tests look. Very short, very simple. Here's a state. Initial state is just a default state which has upcoming but no available, has an empty array. I should have put that in the slide really. But yeah, so that's an action generator for the appointments reducer. Okay. Yeah, and then we had lots of non-React stuff, which was just utils, and we handled that in the normal way with testing. Just seemed to be pretty good with that. So simple things, I don't know if you'll see these later, but expect this function to return that value, all wrapped up nicely and easy to use. So this is the general principles we thought. Shortest possible feedback loops, including keeping the logic out of the components. If you put too much logic in the components, it will be much more difficult to test and much more difficult to maintain in general. Test the reducers, test your utils do end-to-end testing for the bigger loops. And that's where we're doing it with integration. Don't tell anyone, but I haven't done all of those yet. Right, next thing we found was routing. So very basic stuff, really. If you're using React, there's a router. And when a user's logging in, or rather, when a user's accessing any given route, you want to check, are they logged in, are they not? Sometimes send them to a route to log in. Very simple stuff. We found functions like this: check the auth, are they logged in? Otherwise, redirect to something else. Skip if the user's logged in, takes them to the default path. And there's a log out method, which you might want to call for certain routes, like reset password and so on. So implementing that on enter in the route, we found we could just hook these in and basically get all that logic with a very simple, easy to read setup. At least I think it's pretty simple. I mean, you can do an auth check. We've only got the skip if authorized for the main path. Otherwise, you go to the login. So that was that. Very last thing we found was when we dug into reducers, our reducers got bigger and bigger, our state got bigger and bigger. When your state becomes complicated, you obviously need to somehow divide it up to make it easy to maintain, but also so that you don't accidentally tread on namespaces. So our state started to get namespaces like this, and we wanted to just make the reducers do simple actions on these namespaces within the state. And there's a thing already in the Redux library that supports that called combine reducers. So you can create reducers that look just like this, and then just combine them all together in one, and it does a little bit of magic to make sure it will match basically the reducer to this key. Very simple stuff, but good to know. And that's it. So what's the question? Yes. So any questions on that stuff first to begin with?
Did I understand that correctly that you kind of separate concerns for different subcomponents of your state and have separate users? What if you have like a state change that triggers changes in different subcomponents?
It's sometimes component based. It's sort of feature based a little bit. There's the user one, for example, is cross-cutting because it defines if you're logged in or not on any component or any screen. But then you get a lot of them that are just specific to a given page or feature. So if you remember with the demo, the calendar, for example, has its own, the appointments rather, has its own reducer that just deals with the state of that. But the user reducer is used on a higher level in the header. So, yeah.
Any more questions?
Yeah, I always find it interesting, like the NPM packages that you use that solve problems, like NPM class or reselect. Did you do anything that you found useful on top of Redux or React? Like any tools that you use with it that was like not part of the library that you found useful to solve any problems that you don't have?
Well, lots of the web, what you mean, things like Webpack and all that? Or?
No, like NPM class names or like reselect, like these kinds of things.
No, I think we used a couple of little tiny functions. Let me just check. We used one or two helpers. What was the one I was thinking of? Particularly with the reducers.
What did you do with immutability in this application? Second question.
Well,
We made sure that we just did
pure functional reducers, essentially. So there's not much of a problem with that. I'm just looking for what we actually used. There was one helper that was really useful.
Yeah, we just used
assigning, really. That was the only extra ones to help.
be clean with that. We wrote some of our own helpers just to deal with manipulating hashes and combining them to make sure there was no, it was a general problem solved. But that's it. Anyone else? Yeah, okay, so we imported, I can actually bring up the bit of the app to show you. CSS, we used SAS, and we imported per component CSS. Let me see if I can remember what we did. I haven't worked on it since about December, by the way, so I've just got back from a long holiday. I'm trying to catch up, yeah. So what we did was, we created CSS, and our convention was to organize things so that every component has a CSS file, a SAS file rather, and then we could include the globals in that. That's the way we did it. So, I mean, we did it. There's a few other things you can look at. We organized things into screens, top-level components, which are the screens, and then the sort of more reusable components in the components folder. We had a lot of stuff with constants, kind of all these different states and so forth, but also the actions. And then it looks pretty standard after that. So you've got actions and action generators and the reducers here. Not too many reducers in the end. And then a lot of the sort of messy logic goes into some of these utils, particularly dealing with all the video connection issues, which we could, which we wanted to handle and be able to test outside of React.
Just one question about the WebRTC. Why you didn't use like the own API from the browser and you try to use like a...
because there's a lot of more complexity in using a direct one, and we had to use a provider for the actual stream because you need a turn server and you need quite a few things to set up on WebRTC. One of the things we're looking into next is actually setting up an own WebRTC server for this client.
With the browser directly, right? Really can serve like WebRTC now is supposed to really connect browser with browser and didn't have the server.
It does do that. If there's a router in the way, it will route via the server. But if there is a peer-to-peer connection, it's there. It's about brokering that connection in the first place and then setting it up that you need the central server. And if you're interested in helping with that, come see me because we're looking into ways of improving that for them. Particularly, the costs are a bit prohibitive at scale.
So about this,
This is what, as I was saying. So if you want to get involved, we're building paid teams for a lot of these social projects as well. So 1 or 2 developers, and you work on one of them, and it's not for free or anything. It's good. Be a part of a team. So it's an ongoing project. This particular one, they're building up. They're going to add more to it, like this server. And we also do stuff. We do more stuff with React and React Native and some other tech. Actually, we're doing a blockchain workshop on Saturday. So if you want to get in touch more, just talk to me afterwards. I've got some flyers for the workshop, or look us up on here. There's the contacts, but you'll see. So it's all /nextcoder with a 3. All right, thanks a lot.
Thank you very much. The next one is, I don't know, how much of you are interested in football? And how much of you actually want to know or want to predict the scores up for next weekend? Wouldn't it be interesting? Okay, I think, Lian, can you help with this? If you're interested in how to predict football games with Synaptic JS, you should listen up now.
Thanks for the introduction. So this was horrible. We tested it before, and then AirPlay didn't work, and then suddenly my Wi-Fi didn't work. So yeah, but we got it working. I moved a bit closer so you can all see me. well, thanks for your interest, even though no one's interested in football. I'll be talking about neural networks today. Basically, I want to tell you a bit of how they work, a little bit, and how you can implement it yourself with NodeJS. And then maybe you want to improve your algorithm if you're not too happy with it. So that's me. I'm Lian Li. I work in Hamburg. I live there too. Currently, I work for Datenfreunde, and we're developing contextualized news app, which does a little bit of machine learning. But I'm not talking about my company today because I didn't do this on company time. It's my hobby. I'm a software developer, and my hobby is a machine learning guy. And yeah, you can follow me on GitHub and Twitter and maybe on Google Plus if you're still there. So it started when my husband and I, he's also a software developer, and we attended a machine learning course on Coursera by Andrew Ng. In case you know this guy, he's like the total guru. And so afterwards, we did a little bit of implementation, but afterwards we were like, yeah, okay, let's do something like fun with it. So at this time I was in a betting pool in the office, and like every week you have to come up with new predictions for the games, and it's really hard, and you don't usually use the scientific, the scientific method, because of course you're a fan, and then you're wearing the fan goggles, or you were wearing the anti-fan goggles. So I was like, well, this sounds perfect for machine learning. And I want to start with a funny quote by Paul Gascoigne. He's also a famous football player, so that's why he's so clever. He said that he will never predict anything, and never will. And I will also not predict, but I will, the scores for the upcoming game day, which is this weekend, I think. So I don't predict the scores, actually. I predict tendencies, because that's easier. Basically, I predict if the home team's going to win, if there's going to be a draw, or if the away team's going to win. And then you can write down, take a picture of the prediction I made, and you can just check for yourself. And you can bet, and whoever wins the most money is like throwing a round of beer, I think. Okay, that was a little bit quick. So we have to start with what machine learning is. I'm sorry. So the idea behind machine learning, what makes it different from conventional programming, is basically what I'm trying to explain in this little example. So consider that you are a programmer of an RPG game, because you all love it. And so the blue sword now presents the player's action. So we are the AI, and the blue is player. And we want to react with a defense action, maybe. So if you want to build something like that, maybe you have some kind of behavior tree based on the action the player took and maybe your health points. And then maybe you have the option of also launching a counterattack, or maybe you can also drink a potion. So the problem when you are developing an AI like this is that if you wanted to code it, it probably looks like this, so the naive approach. If the player takes an attack action, and then we check our health bar. So if we have more than 75% of health left, so we do a counterattack. If we have between 25 and 75% left, we do a blocking action. And if we have less than 25% left, then we want to drink a health potion. This is the way we could implement it. So we have these thresholds here, and most of the time when you program something like that determinedly, you will just guess. You will just say, okay, 75% feels like a good number. But in complex games, it might be impossible to manually implement all the possibilities that you could look at. You could look at the health bar, you could look at, I don't know, the experience or the level or whatever. So there's a lot you have to factor in, and then you might have a lot of switch cases. And also, maybe we want the logic to change. If like one thing changes, we want the entire logic to change. We don't want to switch through each of those input variables, basically. Okay, so this whole thing needs to be more dynamic. The idea behind this is basically calculus, or also known as math. If we take one scenario, we have what the user did, and then we maybe add how healthy we are. And what we want to get out of this is we have 3 different actions we can take, and which one would be the best one for us to take based on the inputs. So we don't want to add just attack and health points because they're not equally as important, maybe. Maybe the health points aren't as important as the action. So that's why we want to add weights to it. We want to have a weight A and a weight B, and those determine how important this input is when calculating the result. And then in the end, maybe we don't want to have just one answer. Maybe we want some kind of probability distribution. What would be most probable to take? What will give us the highest probability of winning the game? Whatever you can think of. So this is basically the idea. And we need to have numerical values here because we can't times a string. We could, but it doesn't make any sense to a machine. So we would have to think of ways to express our problems in numerical values. So the idea is that once we have our correct A's and B's and C's and D's, we have a model, and that model represents the reality, the system that we're trying to run our predictions on. So I don't have the time to go really into how a neural network works. So basically, we take this, we set A and B randomly, and then we get a result. And that result is probably pretty far away from the reality. So we need examples from maybe from the world, actually, or from the best RPG players. Maybe you want to just emulate the best RPG players. And then you calculate the difference between your result and what the actual result should be, and you try to minimize that. You just iterate over it and change the weights every time you check, did I minimize the error? And if yes, we just go down further that way, and if no, we go another way. That's basically the idea. If you want to know more about it, we can talk about it later. So, funny quote. So George E.P. Box said that models are wrong, but all models are wrong, but some are useful. And basically, that's what you have to keep in mind is that your model is not perfect. It will never be perfect because you don't know what perfect is. Machine learning is used for very complex problems, and usually we use machines because we don't really know. We don't know any better. So the best thing you can have is a close approximation to the result, to the reality. So, okay, let's look at implementation because that's more interesting than talking about it. So I used the library called Synaptic. That's just an implementation of a neural network, which gives us the possibility to not look into the math too deeply, but just use it, just throw something against it, and just hope it works. Okay, so these are 22 lines of code, and basically all you need to train a network. So we need data. We need input data. In this case, these are 2 teams. The first one is the home team, the second one is the away team, and that's their market values. So the idea was what expresses the awesomeness of a football team the best way. Like, if you had to pick one value, which one would you pick? And we decided to just start with market values. And then the output is an array. That is because we want to predict home, draw, or away. But those are strings, and a machine doesn't understand strings. What we can do is have an array that's a reference to something. So if every time the first one represents the home team one, the second one, it's basically a bool. The first one represents the home team, the second one a draw, and the third one represents the away team. So in this case, there were 2 teams, and although the second team was worth a bit more, the home team apparently won. That's what it means. Then we need some data that doesn't have an output because we want to predict the output. That's a lot. That's probably Bayern München. Okay, and then we have our sets. We just build an array out of those objects. So, and then what we need is a network and a trainer. So Synaptic just gives you the possibility to say, hey, architect, give me a perceptron, which is I think the smallest possible network. It's a one neuron network. And then the first parameter is the input nodes, the number of input nodes, and I want as many input nodes as I have input values. And the last one is 3. I could have also just put in output length because I have 3 classes I want to predict on, and that's why I have 3 output nodes. And then in between, you can just define the number of hidden layers. That's basically how many times something gets iterated and passed on through the next layer. I just played around with it a little bit. I do know what happens, but I don't really calculate it. I just try and then see, okay, this seems to work a bit better. And then we generate a trainer for our network, and we tell the trainer to train something. There are 2 attributes. The first one is the learning rate. The learning rate basically defines the size of the steps you take every time you add on another weight. So if you have a weight and then you want to maybe subtract a little bit from it or add a little bit to it and then just go through the next iteration, and the learning rate will determine how much you add or subtract from it. So if you have a big learning rate, it could be that you overshoot the ideal, the minimum, the ideal weight number you want because the steps are just too big and you tend to walk around it. If it's too small, it takes a lot of iterations to get to the ideal value for your weight. Then you can define the number of iterations. Each iteration will go through the entire training set. And then in the end, I have this array for my future matches, and I just run predictions on it by calling activate on the network. It's like a superhero. Network activate. Right. Okay. Did you understand that basically? Okay. Cool. Yes.
How do you define those values for the rate, the learning rate, and the iterations in the first place?
Yeah. So the question was, how did I determine the number of the value for the learning rate and the iterations? And I just played around with it a little bit. I just tried it and decided that it looked kind of cool. Okay, so this could be our output for what we just saw. So first, the first are the activations. So those are the values those are the market values for the teams. And the second one is a probability distribution, which means all 3 values added together will give 1 or 100%. So there's a 100% chance that one of those will happen, and it's distributed as follows. Now, if you can see it, and if we look at it closer, the first prediction says that, okay, the away team is worth more than twice as much as the home team, and it also has it's not twice as high as a probability, but it's like 53 to 30. So that's much higher. But if you look at the third prediction, then we also have the same thing. So the away team was worth twice as much. But for this, the algorithm predicted that the home team will win. So that could mean that everything's broken. It could also mean that there might be some kind of home advantage. That's something the machine will just learn. It will just learn the pattern over time because it's experience basically. And so that could mean, like I said, that there's a home advantage, and maybe it's just much bigger if the market value is smaller. If the team is not that expensive overall in absolute numbers, then maybe the home advantage is just bigger. It just influences the game more. Maybe our machine would always predict home wins. If both teams had the same value, maybe our machine would be biased for home because it just sees this kind of home team advantage. But that's something that you would have to see you have to attack when we talk about optimizing the algorithm. So the thing, what I'm talking right now, the thing is that I don't really know how the machine got there. I just have to be half sure that it just did everything I wanted it to do, and this is just what it gave me. Because I'm not able to calculate the same way the machine did. A lot of it is random, like the starting weights are random, and there's also maybe a random bias to it, just to, well, I'll talk about it later, but there's a lot of values set up randomly, and every time you run your network or you train your network, you might get different values from it. You might get different predictions from it just because the start is set up randomly. Was there a question? No. Yeah.
If you give more examples, then we get opportunity to make the real results, right? If you have more.
Yeah, exactly. So what's very important, the three things you would need for this. First thing is a model, so an idea of which data I want to put in and what kind of data I want to get out. That's your model. Then the second thing you need is a neural network. Take a library. There are a lot of awesome libraries for JavaScript. There are also lots of awesome libraries for Python. And then the third thing you need is a lot of data. Maybe I can show you later, if you have time for a live demo or something. I have all the data for the Bundesliga for the first and second, I think, from 2010, the season of 2010 until today, and it's pretty sucky. So you need really a lot of data, and yeah, I'm also going to talk about this later on. So, right, the next thing we wanted. So now we have a machine that predicts stuff, and we want to know like how well is the predict, like how well does it do? So Synaptic has something for it. We can give our trainer a schedule where we say, so every 10,000th iteration, you've got to do something. And then we log the number of iterations and error. That's something that Synaptic has set up for us. It's just called error. And if we print out what that does, so it gives us an error of 0.19. So what do you think that means?
Error compared to the old values, like
what do you mean?
Like the historic input that you put there,
yeah.
And it's trying to predict, and then the error is like the error compared to the.
Right. So would you say that means that 1 out of 5 times we're wrong?
Yeah.
But that's not what it means. So this error is called mean squared error, and it's very like I thought as well that it was like 1 in 5, and I was like, oh, this is amazing. But actually, it wasn't that. So the mean squared error basically measures the distance between your result and the actual result. It's a vector kind of thing. And the thing is that basically the value is always somewhere between 1 and 0. And it's the distance. Every time you're wrong, it's not a 1, but the distance. So that means that it's very gracious with the error, and it doesn't really tell us anything that we can understand as humans. Like if I tell you it's the mean squared error or the root mean squared error, it's like, yeah, okay, I don't know what it means. So I thought, okay, I need some metric that tells me something that I as a human can understand. And I thought, like, that's easy. So just we do the same thing. We have the schedule here lined up, and then we count our errors, basically. So we have an error counter. Then we go through our training set. That's the set our algorithm trains on. We have the real outputs for that. And then we say, okay, I need to make a classification from my predictions. My predictions were numbers. What I want is that it gives me back the index of the class. I don't know if that's clear. It basically, instead of the distribution, I want this function to tell me I predict home win, I predict draw. And then I just compare. Is that actually what happened? That's the idea. And then every time it's not, I increase the error counter. And in the end, I compare. And then I divide the errors by the length of the training set, and I have an error rate. So that would actually be how often I'm wrong, right? Would you agree? I do make predictions, and then I just count every time I'm wrong, and then I just see, okay, how often was I wrong? Okay, so what do you think that's going to be?
I think you would be wrong every time because your model will not have float parameters, and your inputs are discrete.
Oh no, they're actually integers, or no, they're floats.
Actually, and then
So, I mean, if you output like probabilities and your input is always 1, 0, 0 or 0 or 1.
Oh no, I classify and then I return the index and not the actual value. And then I compare the index. So I know, okay, this one predicted home and this one is actually gave me the result home. So that should work, but good for staying awake. Okay, so anyone has a guess? Like how much will it be, like error rate? What do you think? 4. So the error rate would be 75% then. Oh, 40%. Okay, that's pretty good actually. It's 47%. It's better than actually like tossing a coin, because we have 3 classes. You would have to toss a 3-sided coin. That would give you an error rate of 66% if it was just random. So that's actually better than just guessing. And just that was with 2 input values. We just only take the market value. That's pretty good actually. Okay, so that looks pretty good. Okay, but there's one thing. We made our predictions, we made our checks on the data our model trains with. So how well does it perform with data that our model didn't train with? Like how do we know that? Maybe that was just like a fluke. Okay, so idea was, it's pretty easy. We think of a threshold. So we want 2/3 of a training set to actually be used for training and 1/3 to be used for testing. This way we have data where we know the output, so we can actually compare how well our algorithm does. And also this is data that our algorithm doesn't know about, and I also shuffled it before, so it's not like chronologically. And the testing set is named the cross-validation, because you cross-validate. That's pretty smart. Okay, so yeah, that's what it does. It's just cutting it in 2/3 and 1/3. Right, and now we do basically the exact same thing as we did before with the training set, but this time we do it on the cross-validation set. Now count the errors and then divide it by the length. So what do you think? Is this gonna be better or worse than before, than with the training set?
Worse.
Why do you think it's gonna be worse?
Because there's extremes in the, maybe there's extremes in the set that's not there that aren't performing
It's a bit worse, yes. Yeah, and also it's just data our model doesn't know about. So it's not a lot of data, so yeah. So this is very interesting in terms of, okay, if your cross-validation error is much, much higher than your training error, then you might have a real problem, because that means your model fits the training data really, really well, but doesn't generalize well to the reality, basically, to data it doesn't know. And that's where the learning rate might come in, or like the other like layers. You might want to have more layers. You want to maybe increase your bias. So there's like all kinds of configuration parameters you can change, and then actually you just watch your arrow go down or up, and then you decide, oh, this looks better. Also, as you can see, the arrow like jumps up and down. That could mean that learning rate is too high. We can't reach the minimum. Or it could mean we just don't have enough data. That's probably what it means. But like I can't debug it. I have to try it out and hope that I find the problem. All right. Okay, so this is a list of errors, which is very detailed, and it's not that important actually. So the mean square error is just the average difference between predicted probability and result. Then we have the classification error. That's basically, okay, I classify my my results, and then I just, that's what I did. I count them up and then divide it, and then that was the error. Then there's the cross-validation error, where I did the same thing with the cross-validation set. And also there's something called the F-score. That's very mathematical, but basically precision and recall are 2 values where you basically have your true positives and your false positives, and the true negatives and the false negatives, and you calculate a metric from that. Let's leave it at that. All right, so, okay. This is basically what I wanted to explain, that if you have those blue dots as your training set, and the blue line is your model, is your algorithm. That's for 2D, right? So maybe the stuff that I just showed you could be represented like this. And now you have your real data, you're actually what's happening in real life data, and now it doesn't fit very well, so that's called overfitting or high variance. Variance is basically the error that you get when stuff that shouldn't be that important actually gets weighted a lot, and then you get stuff like this. Or that's the opposite, basically, where you have the same training data and your algorithm doesn't fit as well, but might perform better on real life data in comparison to the model on the left. That's called underfitting or high bias. And bias is basically, I think you've heard about it by now, is the error where you basically should see a change because of an input that has changed, but you don't because you don't think it's important enough. That's what it means in machine learning. Okay, and one of the tasks basically in machine learning is just figure out, do I have an underfit, do I have an overfit, how do I fix that? That's most of the time. Okay, so I tried a few things to improve my algorithm. First, I tried to adjust the learning rate, and I just want to show you what came out, basically. So at first I had like 003, and then I changed this to 001. What you can see is that the error actually does go down continuously, but it's higher. So that's what I said, right? So maybe you will get to the point, but it will take you longer because the steps are smaller. That makes sense. But I could do just more iterations, and maybe I will get a better result then. Another thing I tried, which is just common sense, get more data. So I got I think I got 100% more data than I had, which wasn't that much and still not much. But this is basically what happened. So that's interesting. It doesn't really improve. Too bad. So yeah, that seems like it's a failure, but now I know I don't have to spend more time to get more data because my model is too shitty and doesn't help. Next up, that's also common sense, add more features. I only have 2. So maybe I just want to have 5. So which features would make sense? I thought match day, so which day of the season is it? Because early season, if you're like super smart, that doesn't really make a lot of difference. Also, I have the position in the table, so there's the table, right? And you get points if you score, if you win, and you get less points if you don't. So that also tells you something. And then it's pretty important which day of the season it is, because on day 1, basically everyone's on position 1, or the VfL is probably always on position 18. Okay, so when I added more features, yay! Gets better everywhere. It does make sense also, because I'm just describing my model in a more detailed, better way. So that's actually what I would expect to happen. Whew. Okay, so things I've tried, and you can try as well. Adjust the learning rate, introduce more features, add more data. And the thing I didn't talk about, regularization, it's a math thing. Basically, you add some value to your hypothesis, so it makes overfitting less likely or underfitting less likely. So if you see, okay, I have maybe an overfit here, then I'm just going to increase my regularization parameter, and then it's going to make it all better. Okay, so another funny quote to end this. Niels Bohr, I don't think he actually said that, but it's attributed to him. He said that prediction is very difficult, especially about the future. And as you have seen, it's not even that easy about the present or the past. So there. Okay, I want to share some things with you that I've learned when I started working with neural networks. So like I said, I'm a software developer. I just did it because I didn't have anything else to do. And so I don't think like a machine learning guy, a data scientist, data analyst. But those are the things I've learned. Work incrementally. you can't start perfect. Like no one can tell you you have to take this learning rate and then you have to do this there. No one knows. You have to start with something and then go from there and try to just increase it continuously. Think about the problem, not the solution. You're not like the machine thinks about the solution for you. You just have to explain the problem to the machine as best as you can. And then just try out different configuration parameters and then maybe get some metric, one of those I showed you, or another one that you can think of. And then just see where it takes you. And it's all about the data. So I took Bundesliga data. I tried this with, I added data from the Premier League, and it was worse. Because there are different rules. The teams are all more expensive. They have more teams. They have more days. So it really, you need to think of, does my data really express the problem that I want to solve in a clear way, basically. Like, do you remember when this facial recognition algorithm flagged African American people as apes or monkeys, or like apes, I think? That's because the data was biased that they put in. They had like mostly white faces to train the machine, so it does make sense. It's not, the machine is not racist. Like okay, recommended reading. There is a lot of stuff. I'm gonna put the slides on GitHub, I think, because there are links. So Positronic Brain is my thing, so that's my program, my application, if you want to check it out. Synaptic, that's the neural network library I used. Then there's the machine learning course on Coursera, which is amazing, but really, really gets into it, and there's a lot of math and a lot of developing with Octave, which I hate. Right, and then there's a nice page on Introduction to Neural Networks for people who really do not like math and that kind of stuff. Then Google brought like TensorFlow, that's a machine learning library with Python, which is really, really good to get into. And so machine learning games on Coding Game. Coding Game is an amazing platform. You should check it out. It's basically solving game problems with code. That's pretty cool. So I wanted to predict something for you, but my slides went away. So I'm gonna try. Do we have the time for me to do some live coding stuff thing? Okay, of course. I will try. Now I have to maybe mirror it, or I won't be able to see stuff. Okay, so do you get that it's called Positronic Brain? Who gets it? Oh, what? It's 30 years TNG this year, guys. Yeah, it's Star Trek Next Generation, and the data's brain is called the Positronic Brain. It's 30 years of Star Trek Next Generation. Okay. Let's see if this still runs. Like, I just restarted my computer, so probably nothing runs anymore. But I saved it. I didn't commit it, but I saved it. No! Error not found. Oh, I don't have internet. Ah, okay. I don't know which Wi-Fi this is. I had a problem with the Wi-Fi before because I thought it would be welcome to Delodi, like it's how it's supposed to be, and then it's welcome at Delodi, which doesn't make any sense. I'm sorry, I'm a hater. Let's see. Oh no, the couch is not running. No, I don't want to cancel. I want to Positronic couch start. Go, please, now. Oh shit. Okay, this might take a while because I'm still crawling data from the internet, and this is gonna take a long time. Wait a second. Yeah, I think this is not working as I intended to. This sucks. I had everything like, oh no. We can if you're still interested then. Are you still interested then? Wait, let me try one thing. I'm just gonna comment this shit out and then just give me like 5 minutes. Did I do this? Okay, last try, and then I'm gonna stop. If this doesn't work, so okay, this doesn't train at all, which I anticipated actually because I don't have enough data, like I said. I'm pretty sure it's gonna break now. Let's see. Oh no, it worked, amazing. Wait, let me make this bigger for you. Okay, take a picture now. So Hertha, I think if there are fans, there's going to be Hertha fans. Oh no, you're going to lose. 23% for winning, and then 45. Well, I'm not claiming this is the exact thing, but it's like 52% correct, or 53%. Oh no, it's 53% wrong. So there. Okay, that's it. Thank you. It's better than throwing a coin, actually.
So thank you very much. Okay. Now, after diving into some neural networks and oh, you're leaving. Neural networks and having some insight in React programming. Each of those, or at least the React thing, needs testing. And Frédéric from Campanda is going to show us which are the best ways to do testing in the front end, and why testing in the front end is better than headless.
You can come more on the front if you want. There's going to be some code which is a bit small, so I recommend you to come more to the front. Yeah, so I'm Fred. I work at Campanda as a front-end developer. And if you don't know Campanda, it's like the Airbnb, but for camping cars. All right, so if you want to book a camping car, go on Campanda, and you will find what you're looking for. So today I want to give you an introduction to testing JavaScript, which runs in the browser. And I'm curious, how many front-end developers do we have here? Yeah, and how many front-end developers do testing? Cool. So for those who didn't raise their hand, I'm going to set the basics of what test-driven development is. And this applies to everyone. So the first rule of TDD is that you must write a failing test before you write any production code. You all agree? The second rule of TDD is you must not write more of a test than is sufficient for it to fail. And the third rule is that you must not write more of production code than is sufficient for the failing test to pass. Let's illustrate this with a little example, right? So I'm writing my test here. I expect the string hello Fred. Test is passing. I can continue. Then I have my actual. I get my object with the function greet, and I pass it the parameter Fred. And I already have my first error. Get my object is not defined. So I can start to write my production code. I declare my function get my object. Test is still failing. I return an empty object. Test is still failing. I declare my greet function, and my test is passing. Now I can go back to my tests. Now I assert that expected is equal to actual, and the test is failing again. Hello Fred is equal to undefined. So now I can return hello Fred as a string, and that will make my test pass. I think you got the idea. Like, this is how we try to do TDD at Campanda. We don't always achieve this cycle, but like that's what we aim for. So why are we actually testing? Like, of course, we want to increase code quality. We want to deploy and ship our code with more confidence. Tests are also really good self-explaining documentation, which is always up to date. Like, if you don't really know how to use the library, just check the test. And by reading the test, you will probably understand how to use the library. And the same for you when you write a library, please write test, because someone who is going to use it is going to read the test in order to understand what can I do with this. Also, it's easy to refactor, because if you break anything, the test will tell you. And I think for front-end developers especially, we already have to deal with so many problems, different browsers, these kind of things. If we can write some tests to cover our code, I think it's already a good thing. What are we testing in the front end? Might be a bit different from when you test in Node. Most of the time I'm testing like user interactions, events. I'm testing DOM manipulations, things that appear, disappear. Of course, some client-side business logic also. And from time to time, I have some AJAX requests. My favorite testing stack, I think, is familiar to most of you. There's Mocha.js for the testing framework, Chai for the expectations, Sinon, which is like a magic library to mock and fake everything. You're going to see a few examples later. And most importantly for me is my browser. I really like to run my test in the browser because I'm a front-end developer and I love my browser. I use Chrome, by the way. And I like to fire up a little gulp live reload server, which just refreshes the page every time I go saving a file. And this really supports the TDD cycle. So I write my test, save the file, I see the test failing, write the production code, save the file, see the test passing, and so on and so forth. So yeah, for an example, let's create a date picker together. This was actually a requirement. We had that Campanda recently. We had to create a new date picker. And we couldn't really find any library that was fitting the needs we had because there was nothing which was working without jQuery. So we just decided to write our own. And of course, we did it with tests. So just to give you an idea, that's how the date picker is going to look like. You click inside, you have a calendar, you can select dates, it closes, and you can go on searching. So we already have here a test running, should initialize the date picker with a given element. Can everyone read this code? Yeah. And we have a date picker object which has an empty init function. And this test is passing. So I can now rely on these 2 lines of code as a setup for all my other tests. So first requirement is that when the user clicks into the date picker, into the input, the date picker should show up. So I use these 2 lines of code, which are still passing. And now I can start to write my actual test. So I would start first to create an event, which is a focus event. And I dispatch it on the input that I created before. And the test is still passing. And then I'm going to query the document for an element which has the ID date picker. And I expect this element to be OK. So it shouldn't be null or undefined. And the test is failing at this point. So now I can start to implement the production code. I will implement in this init function, and I will just like add the event listener on focus on the input element, create a div with the ID date picker, and append it to the document body. And this makes my test pass. So what I wanted to show you here is that it's really easy to test like events and user interactions and check if something is appearing in the DOM or not. You can test all these kind of things. Something I come across a lot also is like how to force myself to test event stop propagation or event prevent default. And that's pretty easy actually, because if we just take the event we had before, we can use the Sinon library to add a spy on the stop propagation method of the event. We dispatch the event on the input, and then we expect that the spy has to be called. Test is failing because the method hasn't been called. And then I can just go on, like, implement this method in my production code. So really, this TDD cycle, every production line I want to write, I'm going to think about the tests for it. And the test is passing. Beautiful. A bit later in my test writing, I come to the point where when the user clicks on the date, I want to add the class selected so that he visually sees that he selected the day. So same here, I would just go on querying this day element inside the DOM, and I would use the native method click that is available because I just got this element out of the DOM. And I would expect that this element now has the selected string inside the class name. Yeah. Another thing, when the user clicks on the day, we want to close the calendar because he's done with selecting, but we don't want to close it right away. We want him to still visually see the selected day and then a bit later close it. What we want to do here is force ourselves to write a set timeout of 300 milliseconds before we make the date picker disappear. For those who don't know, with Sinon you can use fake timers. It's a really nice thing. You can fake the clock, fake the time. So you just go on clicking on a day, tick the clock 299 times, expect that the class hidden is not on the date picker yet, tick 2 more times, and then expect that the class is there. And restore the clock, of course. You can also mock browser methods when you are testing. For example, we had this thing that the date picker would always be initialized on the today's date. And then we had a lot of tests that were related to this, like, okay, the user shouldn't be able to click on days before today, actually on the day before the day of tomorrow. And like when you click on next, you should show the next month. Like all these tests, they had a context which was related on today's date. And it's pretty easy to set up as well. You just use the setup and the teardown functions from Mocha. And then you just stop the now method of the date object. And you just hard code a value here. That's now, in every test, you know, this is the context I'm going to run in. And it's much easier to make these assertions. Yeah, like I mentioned already, I really like to run my test in the browser. It's familiar to me. They have the dev tools. I can debug, I can open the console, I can understand better which are the errors, why the test is failing. I really like how easy you can just click on a test and just run this one. You don't need to go adding only or on your code, these kind of things. And also what I usually do is that when I have a stack of tests which is passing, I just switch tabs to my production code, and then I try the feature. I see if the test I wrote is actually enough to make the feature work. And then I realize, oh, I kind of didn't think about some edge cases. I go back to my testing tab, and I go on writing some more tests, and so on and so forth. Like this TDD cycle goes on until the feature is ready, of course. It's never really ready, but... Yeah, of course, if testing, like seeing the test pass in the browser is not enough satisfaction for you as a developer, for me it is, but you can run them also in a headless browser. I run them in Phantom.js. I have some bad experiences with it, but you can go online, you will find a lot of resources about this. You can integrate this in Jenkins, Travis. I don't really want to elaborate on this topic now. A few more tips. If you find a bug, write a test first, so to make sure that you're going to cover this in the future. Do TDD while pairing. I think like this is really awesome. TDD is meant for pairing. Your tool, one writes the test, the other one goes like solving them. It's like a challenging game that you go on, and I think it really helps for this. And you learn a lot also because everyone thinks a bit in a different way. And in the refactoring phase also, you see how the other guy is going to refactor. He suggests you like, hey, I wouldn't have done that like this. Really try to do pairing a lot when you do TDD. Use the web APIs in your test. Like you could see in my examples, I'm using all the methods available in the browser, all the objects. They are there when you run the production code, so use them in your test. They will help you a lot to test the things that you want to write in the production code. Don't try to test the browser though, like it doesn't make any sense. And don't try to test the libraries you use. The developers who maintain them, they should test them. If they don't, then, I don't know, stop using them. Just write JavaScript, it's good enough. Yeah, that was it. I really hope that some of you who didn't do TDD in front-end JavaScript before will do it now. And if your company doesn't allow it, then we welcome TDD refugees at Campanda. And if you have any questions, then hit me. This one? Yeah, totally. Absolutely, if you want. I mean, for me, the purpose of this is not to test how the code runs in this particular browser. So it's more like I like to see the test in the browser. I like how dynamic the interaction is with it. But yeah, you could.
So like for continuous integration, you could say we're supporting these browsers and just run them all.
Yeah, you could do that. I'm not sure that...
It would be nice if you have like a browser stack and then the test fails on Chrome but fail on Firefox.
Just a quick question. How you break down the tests? I think that's sometimes hard to understand when to still continue trying to put the logic on the test or already jump to creating the code. You know, how you break the
I'm not sure I understand the question, but with this TDD cycle, I keep on writing tests until it fails, and then most of the time I'm pairing, so then I leave the keyboard to my mate and I say like, hey, your turn. But was this your question?
No, it's more like, did you finish the feature test, like you create the test for all the feature that you want to create, or you just try to do middle and then middle of the...
No, every single production line I write a test for, so like if the feature, like I will write test until the feature is done. I mean done, like until I think I met the requirements.
Okay.
So I will, maybe sometimes, like I said, I will stop writing tests and I will go test my feature manually, because that's usually how I find bugs. Like I don't think about something, I go clicking around and then I see like, oh, okay, there's something here. I try to reproduce it, I try to understand it. Once I understood it, I'm gonna try to write a test that's gonna fail for this particular scenario. And then I'm gonna try to solve the test. Usually once you're able to write a failing test, the production code kind of comes on its own. It's not always easy to reproduce every bug you find manually in a browser with a test, though. Like sometimes it's really...
I have one question. Do you also use other test libraries? I don't know, for example, Jasmine, and you tested it out because you mentioned like Mocha, I guess.
Yeah. No, I'm like, this is my favorite stack. Like, same, like I don't use any other browser. Maybe sometime I will have the opportunity to try something else out, but this works pretty well.
I'm thinking about integrating Jasmine right now, but maybe we switch to another stack and it's that good. Maybe it's also nice to know that there's something else.
The great thing about these three libraries I mentioned is that they all work independently. Like you don't have to use these ones together. You can also use them like with something else. And the reason why I like to use those is that I use them also when I do JavaScript on the backend, which happens from time to time.
So you said it's a great tool to find bugs when refactoring, obviously, but it's also, I think, a heavy weight when refactoring, because you not only have to refactor the whole code, but you also have to think through the entire structure of your test. So how much of work when you do refactor or change structures goes into reworking production code, and how much work goes into, how much percentage goes into structuring the tests?
Sometimes it's a lot, and it's really painful, but that's what you have to go through when you want to do TDD. Like, if you change something in your code, you have to adapt every single test that was dependent on this thing, because you want to see all your tests being successful at the end. So if you just refactor a tiny bit, which is just depending on one test, and you spend too much time on it and you don't get it to work, then just revert, like try to make small refactoring steps, you know? Don't try to like refactor the whole at once. Just like focus on one little part, refactor it, make the test pass, and when this is done, then go on the whole chain and make sure that it's working everywhere. But yeah, sometimes it takes a lot of time when you suddenly like, it was totally wrong what we did, we have to rethink the whole thing, and then you go changing it. But what you do when you do this also, like how I do it sometimes, is that I start refactoring my tests actually, before refactoring my production code. I'm like, oh, okay, this was wrong, like my test made me the wrong production code, so I'm gonna start to refactor my test. It's gonna make my production code fail again, and then I'm gonna adjust and adapt my production code to the tests.
One question is, maybe it's a little bit bad question, but how do you sell to your customers that you're doing also most of the effort into testing? Because that's the point where we have always troubles to convince our customers that test-driven development is a better way to go, to be stable in the future, but most of the customers don't want to pay. So I
I work for one company, so like this is we don't have customers, like my customer is my company, but we don't really ask for permission. We just do it. Like we consider this is part of our job. If we want to be professionals, if we want to produce quality software, then we should test it. Like I said, we welcome TDD references.
You have to test it somewhere.
So if you test it in these small cycles at the beginning, it's often cheaper than testing it once it's live in production.
It's also in the long term cheaper because you have less bugs and you use less time to find those bugs and fix those bugs. But if you sit in front of a customer and tell him that in the beginning it costs double the price, then he's mostly saying, okay, I don't care about the future.
But just don't give the other option.
Yeah, like there is no other option. Like that's the price. That's all. The people who want quality software, this is the price they have to pay.
Why does it take double the time? Like, in my experience, TD doesn't take fast.
On the beginning, yes, but it totally pays off. Like,
I know that people say that a lot, but it's never been my experience. Like even implementing new features, it just takes less time because you have to think how your software is going to work anyways, and then why not write it down? And then you don't have to think about it every time, but it takes time.
For some developers it takes double the time.
Sorry?
For some developers it takes double the time. For other developers they imagine the code and it's perfect when it comes out.
Really?
Okay. Well, I don't really, yeah, these unicorns exist somewhere, but it's like...
I just think it's a myth that writing tests will take more time.
I guess it also depends on how flexible you are in developing your software. For example, if you do Scrum and having sprints and writing tests, and in 2 weeks the customer says, okay, I want completely different software, then you have the same problem. Every 2 weeks it could be that you have to completely refactor your code base and refactor the test base, and it will always make that...
Refactoring is also easier with tests, actually.
Yes, to find the things and to understand it, of course, but you have the effort to change both the tests and the production code.
Yeah, I get that, but I still maintain that just the time you spend remembering things, that's just, you don't have to anymore. That's what I feel is a big win.
But you don't have to test so granularly, right? You can test, you don't have to test everything so much. You can have a bigger interface on which you're testing with more logic happening behind the interface that makes a refactor much easier.
I agree with this. I think like if you really don't have a choice, then like it's never possible to really test everything. Like try to go on a higher level of test. Like just do integration tests. You know, sometimes it's good enough. Just at least you have something. You know, a bit of test is better than no test at all. Try to do the best you can for this.
if you're selling prototypes, then tests will cost more. But if you are selling a software that you need to maintain for a longer period of time, it is economically cheaper to have tests.
So we have, for us, we found a middle way somehow. So we're trying to make TDD, but we also say, okay, we do all the business critical paths, so testing them completely, and every other thing we just, if we found a bug, we will integrate it. That's how we do it. But we cannot test everything. No one will pay for it.
Any other questions?
But I want to thank you very much for coming. Hope to see you in the next time, which might be next month or the month after next month. I'm not sure about it because I'm going to the holidays and things have to be prepared and whatever. So I'm not sure if we can manage it in 4 weeks or so. But it's going to be happen and not in 1.5 years or so. I guess testing would be a good topic.
Cool, thanks. Yeah, also from our side, thanks for coming tonight. I'm pretty sure like we would be in for organizing another one because that's our plan. So we want to do this about every 2 months because obviously it takes time to find speakers, define a topic. But my call would be also if you're attending other meetup groups on different topics, programming languages, infrastructure, I don't know what. And yeah, you have ideas there to invite someone who's not living in Berlin. So we're happy to jump in there and support local tech events because we are also local tech recruitment platform. So we see that as part of our DNA to support stuff and like give back to the community. I used to be a software engineer myself. So I think like that was also like always important to me. And like I've been running events for 6 years now. So please talk to us if you have ideas. I mean, this time we only brought Lian here, the French guy and the English guy were already in Berlin, luckily. So thanks, Fred and Jonathan. So yeah, thanks again. Let us know if you have any ideas. We're gonna put all the presentations up online. So we recorded everything. If anyone has privacy concerns, please talk to us. So we're gonna try to get you out of the pictures. And yeah, hope to see you next time. Thanks.